Basics of organic nomenclature. UPAC system, International Union of Practical and Applied Chemistry. So we will start with the first, hydrocarbons. Hydrocarbons means the compounds containing carbon and hydrogen. First comes alkanes, and then comes alkenes, and third comes alkynes. Alkane, the general formula is CnH2n plus 2. Alkene, general formula is CnH2n, and alkyne, the general formula is CnH2n minus 2. Now we will explain in detail what are the alkane goes, how does the alkane naming goes, and how alkene and how alkyne. Let me go to the next. Alkanes. As we know, the general formula is CnH2n plus 2. When n is equal to 1, we have C1H2 into 1 plus 2, that is C1H2 plus 2, that is CH4. Now comes the structural formula. Next comes N is equal to 2. C2, it is CnH2n plus 2. So it is C2H2 into 2 plus 2. That is C2H4 plus 2. That is C2H6. Now the structural formula comes C bond C. Now as we all know, carbon has 4 valences. That is carbon, the electronic configuration of carbon is 2, 4. The last cell, it has 4 electrons. That's why its valency is 4. We have done it in the bonding. That is this 4 electrons, and hydrogen gives 1 electron. So this is how they make the covalent bond. Similarly, we are here getting ethane. This is methane. So the name here, it is ethane. One, two, see 1, 2, 3, 4. Now for this carbon, this is very important to count like this. 1, 2, 3, 4. You do not count like this 1, 2, 3, 4. No, for each carbon you should count it 1, 2, 3, 4. Again for this carbon it is 1, 2, 3, 4. Okay, so we get the condensed formula as CH3, dash CH3. Got it? We want go to next, that is N is equal to 3. You can do yourself also and try once, that is N is equal to 3. So how we can do? C3H2 into 3 plus 2, that is C3H6 plus 2, this is C3H8. Now again the structure C bond C bond C, and this is known as propane. So once we get this carbon, so it should have 3 more. Already one valency is there. So 1, 2, 3. Then for this carbon, 1, 2 is already there. 1, 2. Then one bond is already here. So 1, 2, 3. So the condensed formula is CH3, CH2, CH3. Now this is called propane. Next we will go on to butane. N is equal to 4. That is C4H2 into 4 plus 2. That is C4H10. So we get C bond C bond C. Now we get 1, 2, 3. You should count each carbon with 4 valencies. Now this carbon 1, 2 is already there. So 2 more hydrogens. Then again 1, 2. Again for the last carbon it will be CH3. So we will move on to the next. I'm writing it here once again. CH3, CH2, CH2, CH3. This is butane. Then comes pentane. N is equal to 5. It is C5H2 into 5 plus 2. That is C5H12. This is called pentane. And like this we have hexane, heptane, like that. So for pentane also we will do 1, 2, 3, 4, 5. So it is CH3, CH2, CH2, CH2 and CH3. See, it is CH3, CH2, CH2, CH2 and CH3. Now, if you jot up the whole thing, what do we get is, we can do it right from the beginning. Methane, ethane, propane, butane. We have methane, CH4, ethane, C2H6. Then we have propane, C3H8. Then we have butane, C4H10. So it is CH4. Now this is CH3, CH3. Now this is CH3, CH2, CH3. Then CH3. Do you understand? CH2, CH3. See, we have a increase of CH2 group from each earlier member. So that's why this series is called homologous series. What is it? This is called homologous series. Homologous series is series of compounds differ with CH2 group. Understood? And the main criteria for organic chemistry, main criteria of carbon to show such huge compound or to form such huge compound, form such huge number of compounds is catenation. What is catenation? Catenation is the power of making bond with itself. Now once again I am explaining what is catenation. Catenation is the power of bond with itself. See, only carbon can do this. Catenation. C bond, C bond, C like this. No other element can do this. So it's a specific, unique property of carbon. That is catenation. Now next we will move on to alkene. This the whole organic chemistry stands on this catenation property of carbon. We will move on to alkene. General formula CnH2. Now it will start with N is equal to 2. So C double bond C. So this carbon already has 2 bond. So it will get 2 hydrogen. Now this is also will get 2 hydrogen. Now you can write this way also, like hydrogen, hydrogen, and then hydrogen, hydrogen. No matter. These two are same only. But the thing is how this double bond comes. Now see, now this is called ethene. Now we already have ethane, no? Now if these 2 hydrogen goes away with their electrons, now this carbon will left with these 2 electrons. Now these 2 electrons combine and form the bonds. This is how double bond comes. And that's why methane cannot do with double bond. This is the unique property, double bond. This is how this ethene comes. Now we will move on to the next. That is N is equal to 3. That means it will be propene. That is C3H6. And the name is propene. Now we will do 1, 2, 3 and 1 double bond. Now this 1 double bond means if we take this carbon 1, 2, 3, 4. Now if you take this carbon 1, 2, 3, 1. If you take this carbon we can do 1, 2, 3. Now you can do like this also, double bond C, C. Double bond you can put here also. The same thing. Both are the same. So what we get is CH3, CH, double bond CH2. Next we will move on to butene. butene, C4H8, 1, 2, 3, 4. You can put the double bond here. So this, for this carbon it is already 1, 2. So it is 3, 4. If you take this carbon 1, 2, 3, so it is 1. If you take this carbon 1, 2, 3, 4. If you take this carbon 1, 2, 3. So it is CH3, CH2, CH, double bond, CH2. The name is 1-butene. Now why this 1 comes? Because if you number like this is the position of double bond is in between 1 and 2. If you number like this 1, 2, 3, 4, then it is 3 butene, but 3 butene won't do. According to this, it is 1 butene. This means the position of double bond is in between 1 and 2. First carbon and second carbon. But if we take this way, we will get 3-butane, which is not accepted because this double bond gets the higher position. Double bond always should get the lower position. We should name it like same, like the way, so that it can get the lower position. Okay. This way we can do 1, 2, 3, 4. Butene. In this way we can do 2-butene also, that we will discuss later on. Now we will move on to pentene, C5H10. In the same way we can form double bond 1, 2, 3, 4, 5. So this is CH3, this is CH2, this is CH2, this one is C, H, and now the final one is CH2. In the same way, now we will move on to alkyne. Okay. Alkyne, the general formula is CnH2n minus 2. N is equal to 2 again. So it is C2H2 into 2 minus 2. That is C2H4 minus 2. That is C2H2. So if we do like this, now how this comes? The bonding structural formula C triple bond C H H. In the similar manner, if we did it in ethane like this, again if the 2 hydrogen goes off, this will form the triple bond. It is the same way, and the name is ethyne. Now, the common name for this is also important. Sometimes in exam it comes. So you should remember this. Common name is acetaldehyde. Acetaldehyde. Sorry, acetylene. Acetylene. This is acetylene. Next we will move on to N is equal to 3. So C3H2 into 3 minus 2, that is equal to C3H4. So we have 1, 2, 3, 1, 2, 3. So we will have 1, 1, 2, 3. Then this carbon 1, 2, 3, 4. So it will not require any more hydrogen, but the final one requires. So it is CH3, C triple bond CH. So this is propyne. Propyne, ine. See, we have started with ine. Similar way we will do butane, pentyne, and so on. Let us see how this butane comes. N is equal to 4. So it is 1, 2, 3, 4. So it is 1, 2, 3, 1, 2, 3, 4. So this carbon is over. Now this carbon, it will require one more hydrogen, and for this carbon 1, 2, so 3, 4. For this carbon it is 1, 2, 3, 4. So it is CH3, CH2, C triple bond CH. So this is butane. Okay, so we will discuss the later portion, that is alcohol and aldehyde, in the next class. For today it is hydrocarbon only. Thank you.